Today is lesson 29, lesson 4.4, multiplying polynomials. The first part here, we're going to go ahead and multiply a monomial into a trinomial. That's what we were doing in example A. But today you'll have various types of polynomials, but working with multiplying a monomial into some form of a polynomial. In example A, you have 5a to the second. Okay, 5a to the second is what is being distributed. Your exponent rules apply. Your 5a to the second times negative 4a to the second. When you multiply that together, you wind up with negative 20a to the fourth. Next, you would take 5a to the second times 2a. When you multiply these two together, we would wind up with a positive 10a to the third. And finally, we would take our 5a to the second multiplied by negative 7, and we'd wind up with negative 35a to the second. Another note, when you look at your answer here, note that this is also in standard form. B, remember you can pause this at any time you need to. Negative 6b to the third, we are going to go ahead and distribute into 3b to the second. And we would wind up with negative 18b to the fifth. Next step, we'd go ahead and multiply negative 6b to the third times negative 4b. When you multiply your two negatives together, you get a positive. We get positive 24b to the fourth. Finally, we're going to take and distribute negative 6b to the third into negative 9. Again, multiplying two negative numbers together, giving us a positive 54b to the third. Again, looking at our problem here, it is in standard form. Example C, note the difference in example C in comparison to A and B. We're actually taking a monomial, multiplying into a trinomial, and we are going to subtract by this monomial multiplied into this trinomial. So we're going to go ahead and break it down into steps here. First thing that would start off here on this problem is go ahead and distribute my 3 into the trinomial. 3 times 15a, 3 times 5a to the second gives us 15a to the second. Go ahead and distribute again. 3 into 2a. 3 times 2a gives us 6a. And 3 times negative 5 would give us negative 15. Here's what we have so far. Our next step is we need to distribute our negative a into the following trinomial. So in this case, we have negative a times 6a to the second. We'd wind up with negative 6a to the third. Next step is negative a times 2a. When you multiply that together, you wind up with negative 2a to the second. And last, negative a times negative 4, multiplying two negatives together, we wind up with a positive 4a. Note when you look at this problem that you are not finished yet. There are still some like terms that you can combine. Like terms, we have actually 15a to the second as a like term, and we have negative 2a to the second as a like term. I'm going to go ahead and just write down this in standard form. Obviously, in standard form, the first thing that we would need first is the a to the third. So we would come up with negative 6a to the third. We go ahead and add our a to the seconds here, 15a to the second minus 2a to the second. we wind up with 13a to the second. We have a positive 6a and a positive 4a. I'm just going to go ahead and take care of that. We've already done that. But positive 6a plus 4a would give us 10a as positive. And lastly here we have the minus 15 or negative 15. So right there we have our answer in standard form. On to our last example, example D. Same scenario as example C. I'd like you to go ahead and work through example D on your own. Give you some time. Go ahead and pause the video now and work through example D, and then we'll come back and work through it together to make sure we're on the same page. Alright, in example D, first thing that we'd want to do is distribute. Distribute your 10z. 10z would get distributed into 10y to the second z to the fourth. After your distribution, you would wind up with 100 y to the second z to the fifth. Next, distribute 10z into positive 5 y to the second z. After you distribute, you get 50 y to the second z to the second. Next, we distribute negative 2y into the following binomial. Negative 2y times yz to the fifth. We'd wind up with negative 2 y to the second z to the fifth. And finally, distribute negative 2y into positive 4y. We'd wind up at negative 8y to the second. Again, looking at our terms here, we are able to combine like terms. My like terms are 100 y to the second z to the fifth and negative 2 y to the second z to the fifth. The variables have identical exponents. They are like terms. You can add or subtract these. So we'd have a positive 100 y to the second z to the fifth minus 2 y to the second z to the fifth. There we'd end up with 98 y to the second z to the fifth. With those two out of our equation here, we'd have 50 y to the second z to the second. That's positive, followed by negative 8 y to the second. This concludes lesson 29, multiplying a monomial into a polynomial.